In this video, we're going to solve quadratic equations using the quadratic formula. When solving a quadratic equation, we're going to follow these steps. Step 1, we're going to write the equation in standard form, which means the ax squared plus bx plus c terms are collected on one side of the equation and set equal to 0. In step 2, we'll determine the values of a, b, and c, so that in step 3 we can substitute those values of a, b, and c into the quadratic formula that's given here. Now remember, the value of a cannot equal 0 because we see that a appears in the denominator, and if a is 0, then 2 times 0 would be 0, and our denominator would be 0, which would make this undefined. So we have to be sure that the value for a is not 0. First, we'll talk about what is meant by the zeros of a function. Graphically, the zeros of a quadratic function occur where the function f of x is equal to 0. Therefore, when we set our quadratic equation equal to 0, we would be solving for those x values where our quadratic function crosses the x-axis. So the zeros of the function are actually the x-intercepts of the parabola. Looking just at the portion for the discriminant, that is the b squared minus 4ac, that's what we find underneath the radical of our quadratic equation. And when we have a positive number generated under that radical, we expect 2 real solutions. That means 2 x-intercepts or 2 zeros of the function. If the value under the radical is exactly equal to 0, then we have 1 real solution because it actually repeats itself, generating 2 identical solutions, so it's really only 1 unique real solution. When the value under the radical is a negative number, that will represent 2 complex but not real solutions. Looking at these graphs, the first graph shows us 2 x-intercepts. Since those can be plotted on the x-axis, this is what a parabola could look like when you have a positive number under the radical, so the discriminant is greater than 0. In this next parabola, the discriminant is equal to 0. Therefore, we only have 1 intersection with that x-axis, or only 1 x-intercept. And in the last parabola, you can see it doesn't touch the x-axis at all, and that's because the discriminant was less than 0. In other words, a negative number. So we'll practice solving quadratic equations with the quadratic formula, and you will see your final solutions looking like one of these. The first quadratic equation is 5x squared minus 3 equals 14x. We notice that this is not in the standard form yet. We should have each term written from highest to lowest power and set equal to 0. So it looks like 14x needs to be subtracted from each side of the equation so that we can collect all terms on just one side of the equation. Now these 3 terms are not like terms, so I just want to put them in order from the highest powered term. That would be 5x squared minus 14x minus 3, and that now equals 0. So there's our standard form. Next, we need to find the values of a, b, and c. So a is the first coefficient, b is our middle coefficient, and c is our constant term. Using the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac, and the negative b and the radical term are all divided by 2a. Now that we have our formula, we're going to substitute 5 for every a in the formula, negative 14 for every b, and negative 3 for every c. So a negative times the b value, this is where we need to be careful because b is also a negative amount. A negative amount is what goes in that parenthesis. So we have a negative multiplied by another negative there, plus or minus the square root of b squared. Again, negative 14 fills in the quantity, minus 4 times a, which is 5, times c, which is negative 3. Now all of these terms are divided by 2 times a. So 2 times 5. Our x value now is equal to negative times negative, which would be positive 14, plus or minus some amount under the radical. So I'm going to take this one term at a time. The quantity of negative 14 squared means we have negative 14 multiplied by another negative 14. So that's positive 196. Next, we have 3 factors that are multiplied. Negative 4 times 5 times negative 3. We have a negative times a positive times a negative. So that will be a positive product. So that tells me to use addition. 4 times 5 is 20. 20 times 3 is 60. So I'm adding 60 to 196. In our denominator, we have 2 times 5, which is 10. So now we need to do some simplification. Under this radical, if we add 196 plus 60, we're going to have 256. So I'll just rewrite 256. Now we're wondering if 256 is a perfect square or if it has any factors that are perfect squares. We can use our factor ladder like we've done many times before. 256 is divisible by 2 because it's an even number, and the 2 goes into 2 once, 2 goes into 5 twice with 1 left, 2 goes into 16 8 times. Since it's an even number, we'll divide by 2 again. 2 goes into 12 6 times, 2 goes into 8 4 times. Divide by 2 again, we're going to get 32. Divide by 2, we get 16. Divide by 2, we'll get 8. Divide by 2, we'll have 4. Divide by 2, we have 2. And divide by 2 to get 1. So we were able to use the factor of 2 with every one of our divisions. Now since this is square root, we're looking for identical pairs. There's a pair of 2's to make 4, another pair of 2's make 4, another pair of 2's make 4, another pair of 2's make 4. We have identical factors again, so here's a pair of 4's to make 16, here's another pair of 4's to make 16. We also have another pair, 16 times 16. So when we multiply 16 times 16, that's going to be 256. So the square root of 256 is exactly 16. So instead of writing square root 256, we know that is exactly worth 16. So what we have for x values would be 14 plus or minus 16 divided by 10. Now we can break this apart with the plus and minus symbol so that we would end up with 14 minus 16 divided by 10, and our other solution would be 14 plus 16 divided by 10. So when I simplify, 14 minus 16 would give us negative 2 tenths. Negative 2 tenths can reduce to minus 1/5. So one of our zeros is negative 1/5, or you could say one of your x-intercepts is negative 1/5. As an ordered pair, that would be negative 1/5, comma 0. For the other solution, when we add 14 and 16, that makes 30. So 30 tenths is exactly 3. 3 is the other zero of the function, or 3 is the other x-intercept. That ordered pair would be 3, comma 0. To check, you can use a sketch of the graph. So let's go ahead and draw ourselves. This is just a sketch. It's not an exact graph of this function. It's just a sketch. So I'll write x and f of x. We have x-intercepts to plot. One of them is negative 1/5, 0, and the other is positive 3, 0. Negative 1/5 would be close to 0, while positive 3, 0 would be much farther from 0. So as a sketch, this is where I would plot those ordered pairs. And the other piece of information we need to know about which way this parabola is opening is by going back to the original quadratic equation. Our lead coefficient is a positive 5. That tells you that this parabola opens upwards, so something like this shape. So to draw the sketch, I know that I would be opening upwards with this parabola. And that's all we're doing, is making a quick sketch.